All right, folks, this is Horner, and this is this is 2006. It's not numbered on your packet, but we'll go ahead and draw everything that we need to on it. Notice that this one's frictionless. We do have a spring, so instead of friction, we're going to have a spring, and we usually call that Fs. We have a couple tensions here. One of those tensions goes in this direction, the other one this way, and then we'll have mg. So let's go ahead and just put everything on our boxes. The one that's hanging is the easiest one to do. So we're just going to have little mg here, and then moving up we do have t. Notice we're not drawing this one left to right. We do that only when we solve it, but for what the College Board wants and what I want on a test is everything drawn in the right orientation according to the diagram. So on this other block we've got straight down, that's not really straight down, it's close enough, mg, and straight up here we should have the normal force. Going to the right we'll have tension. And then going to the left, we will have the force of the spring. This one is worth 3 points. It's not worth 6. Here is the first. Here is the second point. And then the third point is right here. So as long as you have those equal and opposite for each one of those and you have them as pairs, you'll get all the points. For the next part of the problem, it wants you to calculate the tension in the string. So let's redraw our diagram again. We're going to use dots this time, and this time we can draw it however we want to since we're not doing it on the actual boxes. So we know that we have a tension going this way on that first box, and going this way we have the force of the spring. This direction is T, and then this direction we said was little mg, because remember this is the big M and this is the little m. And so we want to calculate tension. Well, just looking at this, we don't know the force of the spring, but we do know mg. So the sum of the forces for this one is equal to 0, and that means that mg minus the tension is equal to 0. So mg is equal to tension. We really don't need to do anything with this side at all because it doesn't really help us find what we want. The mass of this block is 4 kilograms. G is 10, so we're going to end up with a tension of 40 newtons in the line. Remember, that's both this T and this T. Don't add them together or anything. They just have the tension T. Great. So let's go on to the next part. And this is calculate the force constant of the spring. If you remember on that first, so there's the first one, there's the second one. This one is capital M. We do have a tension going in this direction, but going in this direction we have the force of the spring. And just looking at this and knowing that the sum of the forces is equal to 0, we can say the tension minus the force of the spring is equal to 0. So the tension is equal to the force of the spring. From the last part, we remember that the tension was 40 newtons, but on this side, we're going to call this K times X. Remember the force on a spring, so force of a spring is equal to Kx. We need to figure out what X is. We see that the spring starts at a position of 0.20, and that would be our original position. Our final position is 0.25. So at this point we need to find out what is the change in position for the spring. That's 0.25, that's your final position, minus your original position, which is 0.20. So we get a change in position of 0.05 meters. Now we can go back and go ahead and solve for K. So here we've got K would be equal to 40 newtons divided by our stretch, which was 0.05. And so at this part, at this point, we're going to end up with 800 newtons per meter. So that one was pretty easy. Let's go on and look at part D. On part D, now we are cutting the string at point P. So they're going to cut the string right here. When they do that, then this is just going to fall to the ground. And we notice that it has a fall height of about 0.7 meters. So our distance here to fall is about 0.7 meters. We have a 4 kilogram block, so that's the mass of the block is 4 kilograms. And if we think about an equation that we can use to find the time, we remember that the distance something falls is equal to the original speed times time plus 1/2 of gravity times the time squared. So our distance is 0.7. Our original speed is 0, so that crosses off. And the rest that we're left with is 0.5 times 10 times squared. So at this point we've 0.7 divided by half of 10 is 5, divide it by both sides is equal to t squared. So now we just solve, find the square root there, and we should end up with our answer. And our answer here is approximately t is equal to about 0.37 seconds if you use that 10 meters per second squared for gravity. And that is the end of this problem.